VLPSos here. This is a video lesson for Python programming, transparency. This lesson code began with stub 2. Let's see what we're starting with. Running the program now gives me a window with an image that has been loaded and blitted as a backdrop. It's a hand drawing by a student named Heather Broden-Geely. And at the mouse cursor, I have a square of white, and I can move that square around with the mouse. What's happening is obvious. The square is blocking out the drawing behind it, and I can move it around to block different parts of the drawing behind it. This is every frame, the drawing is refreshed and blitted to the screen, and then at the location of the mouse, there's the layering of the mouse white square on top, and so I can move it and it'll refresh to block a different location. Pretty basic. But what we're going to do now with this is we are going to introduce the concept of transparent colors or semi-opaque colors. Colors that give us the illusion that when they're in front of something, we can see all of or a part of what they're covering in the background, as if we're looking through glass or fogged glass. Let's take a brief look at the code to see what we're starting with. We have a picture that was loaded. We also have a surface that was created to be what we call the mouse surface, the square that's blitted approximately at the mouse location. We fill the mouse surface with white. So in the frame loop, I have mouse surface.fill, but this time I'm giving the color tuple as numbers. We can certainly get colors from the palette that we're used to loading and then referring to, where all of the color tuples are stored. But this time, because the actual numbers are going to be important to this part of the lesson, we can see that we're filling with 255, 255, 255. 3 values, red, green, and blue, all at maximum value to give us pure white. What we're going to do is we're going to introduce a fourth value in the color tuple. And that fourth value will be the amount of opacity that that color is. Some people say it's a transparency value. But the higher the value is, then the more opaque the color will look when layered on a screen and used to give the illusion of transparency. The lower that fourth value is, the more transparent the color is when used in this layering technique. So we're going to introduce a fourth value in the color tuple that we fill the mouse surface with. And we're going to make that a variable called alpha, and we'll call it alpha value. This fourth value, the most common name is alpha, the alpha value. So our color tuple is now red, green, blue, alpha, when we're using colors that can give us the illusion of opacity or transparency. This needs to be an integer, no less than 0 and no greater than 255, just like the other color values. But we've assigned it a variable so that we can change it and we can experience different amounts of transparency. And we set the initial value up here before our frame loop to be 125, right in the middle of the range from 0 to 255. Also, something that we had to prepare in order to give this illusion of transparency is the surface that we're going to use alpha values on, four color values on, to give this illusion of transparency. We needed to run or use the convert_alpha function on the surface. That makes the surface instance capable of dealing with the mathematics involved in giving us this illusion. So we can't forget to append this function to the surfaces that we want to be able to handle transparent colors. I'm going to run, see what we got so far. So we've filled now the square that we're able to move around with a semi-opaque color. And the surface that it's on is capable of handling the math involved in mixing the two pixels to create the illusion of opacity. That mathematical process is called lerping. We're lerping colors. Lerping is short for linear interpolation. Linear interpolation is a mathematical process similar to averaging. And what we're lerping, the colors that we're lerping, are all the colors that are on the square mouse surface and the pixel colors on the image behind them. At every single pixel location, there are two colors. There's the color on the mouse surface, and there's the color on the screen or the drawing behind. And what's happening at each of those locations with those two colors is they are mathematically being combined to come up with a third color that we actually see coming from the monitor. When we do this combination, this lerping, this mathematical algorithm to all of those couples of colors, it produces the effect, the illusion of a transparency happening, of the white semi-opaque surface on top looking as if it's like a frosted piece of glass, and then we can sort of see the image below as a combination. Now, this is an illusion because the monitor is only capable of generating a single color at every single pixel and sending that light into our eye. The monitor is not making two colors and then layering them, and one of which has some amount of transparency. It doesn't send out two light signals and then our eye deals with it. It's done mathematically. There is no such thing as a transparent color, so to speak. There's only a color tuple that includes a fourth value to tell the computer how to do the math in order to produce the illusion. We can experience different levels of opacity by changing that alpha value. This alpha value we put as a variable so that we can increase and decrease it. We're now going to code for the mouse buttons left and right to be able to add and subtract to this value so that we can test and observe different opacities. To prepare for that, in the event queue, under the event type 5 or 1025, we made on the event that the button was 1, making the add alpha boolean equal to true. And on the event that the button that we just pressed down was 3, subtract alpha is equal to true. So when we press the left, we're going to increase, we're going to add, and the right is going to be for subtracting. Now we need the complementary event, the mouse button up event, to turn those booleans back to false. So this is a hold down effect. We hold the left down, then we turn the boolean on, releasing the button turns the boolean off, or true and false. Now based on those booleans, we're going to add to the alpha value variable. That code has been commented out, so we can introduce it very easily by uncommenting it. The alpha value is going to change. We're going to add to it on condition that add alpha is true, and we're reassigning and adding each time only 1/10. That's so when we press the button, it doesn't increase so fast that we can't see it. We need to increase at a level where the human eye can experience this, because the frame loop is going to be going very quickly. So 1/10 per iteration of our frame loop. Now, just like a red, green, or blue number in a color, the alpha value cannot go over 255. So if we're increasing it, we need to make sure that it never goes above 255. assigning alpha value or reassigning alpha value to be now a call to the minimum function with 255 and alpha value in it means that if the alpha value just got above 255, then it'll be sure to be reassigned to be this lower value of 255. In other words, this line of code makes it go back to 255 if it should go too high. And likewise, if we're subtracting and reassigning alpha value and it goes below 0, which would break our program if we're using this value in a color tuple, then we're using the maximum function to choose either 0 or alpha value, which means whatever is the higher, which means that when alpha value goes below 0, 0 will be chosen if we're looking for the maximum between a negative and 0. And alpha value then can never go below 0. This is another way of controlling a maximum and a minimum of a number so it doesn't break our program. Now that we're sure that we have a value that can be used in a color tuple, then we assemble our color and fill the mouse surface with it. Something else that we're going to add is typing or rendering a font as a graphic, the actual value of the alpha value variable, and blitting that to the mouse surface. In other words, these two lines of code are going to draw the alpha value right on top of our square that we're moving around so that we can see how much opacity we have in that color that we're using. Let's make sure that we have these booleans uncommented and see what our program does for us. I can move around a semi-opaque square. I can get this illusion of being able to see slightly through it to the drawing behind, and I can experience any part of the drawing by moving it around. The red 125 is the current alpha value, the current amount of opacity that that filled in color has. And by pressing the left mouse button, I can increase that value. And I can immediately see how that value is affecting how well I can see through or get the illusion of seeing through that mouse. If I go up to 255, it doesn't allow us to go over. That's pure white, fully opaque, not transparent at all, and I can see none of the drawing behind. I can use the right mouse button to take this down fairly slowly, and I can experience a higher and higher degree of transparency until it's very light at an alpha value of 46, and I can go all the way down to 0. That's fully transparent. I can't see anything of the square in front. I recommend that you play with this, experience it for yourself. We have one more thing to do. We have previously gotten into the habit of importing all of our colors from a separate file that we call palette. This is a really good way of organizing a dictionary of many colors that can be used in a program so that we're not writing a big blocks of text in every program for all of the possible color tuples that we're using. If our colors now are going to be used for transparent or semi-opaque, this illusion that we're introducing, then all of our color tuples have to contain that fourth value, which means that the palette that we have been using needs to be updated. It needs to be updated with that fourth alpha value. So what I'm doing here is I'm making a comma 255. 255 for an alpha value is fully opaque because most colors that we want to use are going to be fully opaque. If I include a 255 value in every single one of my colors in the palette, then I've prepared that palette to be compatible with programming for and with transparency. This is going to be our updated palette file. We're going to save it and then use that file in all of the future lessons and coding examples. Here's a note on this word lerping. LERP stands for linear interpolation. It's a mathematical algorithm similar to averaging. It's a little more complicated. It's a way of averaging color tuples, but also including the fourth value and how it influences that average. So it's similar to averaging. Now you have seen that color tuples most often have four values: red, green, blue, and alpha. The alpha value is how opaque the color is. Higher value means more opaque, lesser value means more transparent. This gives the illusion that surfaces can be transparent or semi-opaque when layered in a program. It's an illusion accomplished by a mathematical color tuple mixing algorithm called lerping, which is kind of like averaging. Your task is to take this code file as a stub and add a pause surface that may be toggled on and off with the space bar. When pause is on, the user should see a surface filled with a semi-opaque primary color overlay on the majority of the screen. Draw a border around the edge of the pause surface and have it centered within the screen. In other words, a pause surface that has a very large overlay on the regular screen, but you can kind of see what's below it by being able to see through it by having it filled with a semi-opaque color. Have fun.